Hey, what's up, Algebra 2? It's Ryan. Today we're going to be working on solving radical equations. So solving radical equations are going to come up a lot in future math classes and just math in general. In fact, actually, I think earlier this week, on a math meet sort of test, a bunch of problems came up that were very similar to some that we'll go over today. So hopefully by the end of this lecture, you'll become we'll go over some of the steps involved in solving radical equations, and hopefully you'll become just a little bit more familiar and comfortable with solving them. I'll also say that shortly I'll be posting another video where we just do even more practice problems for solving radical equations. So after we finish this lecture and you sort of learn how to do it, if you want some extra practice, you can go over and look at that video too. Okay, so let's start with example 1. So we're given this radical equation, -2 times the third root of 2x plus 7 equals -6. And so essentially, when we're saying asked to solve any equation, we want to isolate x. And this is how I think about solving any equation. We first want to see what we're doing to x and just do the exact opposite of that. Okay, so we want to isolate the radical. Okay, so this is going to be our first step. So when I say look at what we're doing to x, we're multiplying by 2, then we're adding 7, and then we're taking the third root of that, and then we're multiplying by -2. Okay, so we want to go from the outside in. So we first want to get this radical by itself, and we do that by getting rid of this -2. What's the opposite of multiplying by -2? Dividing by -2. So we divide both sides by -2, and we end up getting the third root of 2x plus 7 is going to be -6 divided by -2 is +3. Okay? Now, what we want to do here is we want to raise it to the nth power. So where n is going to be our index. So in this case, it's 3. So that by raising to the third power, we have to do this to both sides. We're undoing this radical. Okay, so as I said before, we want to see what we're doing to x and then do the opposite. So by raising it to the third power, we're going to get, this is kind of hard to write, it's kind of awkward, but we get 2x plus 7 equals, and 3 to the third power is going to be 27. So now we can subtract 7 from both sides, and we get 2x equals 20. And then we divide both sides by 2 to get x equals 10. And that's how we solve a radical equation. Okay, so one thing, one important note is that we want to check our answer always with radical equations, because sometimes when we're squaring or we're cubing and we have radicals involved, sometimes there'll be some things called extraneous solutions. So once you solve your equations, always plug them back in. So in this example, we have x equals 10. So we plug this back in, we say 2 times 10 is 20. 20 plus 7 is 27. The third root of 27 is going to be +3. And then we do -2 times +3 is -6, and that checks out. So we know this is good. Okay, you always wanna check for extraneous solutions in when you're solving radical equations, because sometimes you'll notice that you'll do all the steps correctly, and when you get those solutions and you plug them back in, they don't work, and you did not do anything wrong. It's just they're extraneous. Okay, so let's now work on number 2. And we see that in number 2, we don't have something as nice as just the third root. we're raising it to a fractional exponent. We still want to treat it the same. So first we want to isolate the expression with the radical exponent, or the rational exponent, I'm sorry. So we get x plus 2 to the 3/4 equals 1, right? We need to add 1 to both sides, equals 8. So at this point, what we want to do is we want to raise both sides to the 4/3 power, okay? And so while we're doing that, let me write this in first. Why we're raising both sides to the 4/3 power is because we want to raise each side to the reciprocal power. And it says here so that the exponents cancel out. Now let's just think about why. If we remember back to our exponent rules, say we have, let's say we have a to the b power and all of that raised to the c power. That's equal to a times a to the b times c power. So we can multiply those two. So in this case, when we have x plus 2 to the 3/4, sorry, that's kind of weird, if you can see that, raised to the 4/3, that we're multiplying 3/4 times 4/3, which obviously they cancel out and you get 1. Okay, so it just becomes x plus 2. So we end up getting x plus 2 equals 8 to the 4/3. Now I'm going to write this, or when we think about 8 to the 4/3, that's going to be the same thing as saying the 3rd root of 8 raised to the 4th power. Okay? Right, just by exponent rules. And so what's the 3rd root of 8? The 3rd root of 8 is going to be positive 2. So we get x plus 2 equals positive 2 to the 4th power. What's positive 2 to the 4th power? Well, 2 to the 4th is just going to be 16. So we get x plus 2 equals 16. We subtract 2 from both sides. We get x equals 14. Okay? So now let's plug this answer in, right? Because again, we need to check our answer. So we have x equals 14. So we do 14 plus 2 is 16. 16 raised to the 3/4 power. Well, we're first going to take the 4th root of 16, which is going to be 2. 2 raised to the 3rd power is going to be 8. And 8 minus 1 is 7. So this checks out. Let me put this in here. Perfect. Okay. Now let's try example 3. Here, we need to do the exact same thing. We have our radical isolated, but now instead of having one term where we have a 7 or -6 over -2, which is just 3, we have an x plus 1. We're still going to treat this the exact same way. We need to raise this side. We need to square this side to get rid of that radical. So we also need to do it to this side. So remember, when you're doing x squared or x plus 1 squared, remember that it's not just x squared plus 1 squared. We have to actually FOIL it out. And when we FOIL it out, and you can do x plus 1 times x plus 1 and go out and do each step. But we're going to get x squared plus 2x plus 1. And that's going to be equal to 7x plus 15, because squaring it cancels out that radical. Now at this point, we want to move everything to one side. So we get we get x squared minus 5x because we're doing 2x minus 7x. And we have 1 minus 15x, so minus 14, or not 14x, just minus 14. And that will equal 0. At this point, we want to factor our quadratic. So we think of numbers that multiply to negative 14 and add to negative 5. And so we know that negative 7 times positive 2 multiplies to negative 14, adds to negative 5. So we get x minus 7 times x plus 2. And that equals 0. And since that equals 0, we say x minus 7 equals 0 and x plus 2 equals 0 because we want each of these parentheses to be equal to 0. We get x equals 7 and x equals negative 2. Now we want to plug these in. So maybe on a test, you definitely want to write down what you're plugging in. In this case, I'm just going to say it out loud and walk you through what I'm thinking. So first, let's do 7. When x equals 7, we have 7 plus 1, that's 8. Now for the other side, we have 7 times 7, which is 49. And 49 plus 15 is going to be 64, and the square root of 64 is 8, which is what we got on this side, so 7 works out. This is good. Now let's do negative 2. So negative 2 plus 1 is going to be negative 1. Now, I can pretty much already say that this is going to be extraneous, but let's plug this in first. We have 7x, so 7 times negative 2, which is negative 14. And negative 14 plus 15 is going to be positive 1. Now the square root of positive 1 is going to be positive 1. Because even though negative 1 times negative 1 equals positive 1, when we take the square root of 16, we assume it's positive 4. When we take the square root of 100, we assume it's positive 10. And when we take the square root of 1, we assume it's positive 1. And so that's why even though this side equals negative 1, it would not work. So this would actually be extraneous. I'm actually going to write that in red. Okay? Great. Now let's work on example 4. So this is probably going to be the hardest case. And it's the hardest case because we actually have to do it 2 times. So you know how one of our first steps, we want to isolate the radical. So we can just raise to some power. Well, we have 2 radicals. So what we have to do, or we can't really isolate each of the radicals at one time. So we have to do this within 2 steps. So in this case, what we want to do is we want to raise this. We want to square this because we have to square this side first. And so actually I'll write this out. But we have to say root x plus 2 plus 1 times root x plus 2 plus 1. And so this is our left side squared. So when we multiply these two, we just get root x plus 2 times root x plus 2. The roots cancel out, so we get x plus 2. And now when we do this, we get 1 times root x plus 2. And when we do this, we get 1 times root x plus 2. When we add them together, we're going to get plus 2 root x plus 2. And then, of course, here, we end up doing 1 times 1, and we get plus 1. So we simplify this, and we get x plus 2 root x plus 2, and we get 2 plus 1, which is plus 3. Great. And that's this side squared. When we do root 3 minus x squared, we just get that's 3 minus x, right? The square cancels out that radical. So now we want to isolate the root again. So what we do is we want to, well, first we notice that we have a positive 3 on both sides. So what I can do there is I can just cancel that out. And then we want to subtract x from both sides. So subtract x, and we get 2 times root x plus 2. That's equal to negative 2x. We divide by 2. We get root x plus 2 equals negative x. We square both sides. We get x plus 2 equals negative x squared. So we can pretty much just say that, but that's the same thing as having the positive, so we can just say x squared. And so we get, if I just say this is equal to x squared, we can just move everything over to one side, so we get x squared minus x minus 2 equals 0. We factor this. What are two numbers that multiply to negative 2, add to negative 1? Negative 2 and positive 1. So we do x minus 2, x plus 1 equals 0. So this means x is either equal to 2 or equal to negative 1. So let's write that here. Now, of course, we have to plug these back into our original equation to see if they work. So let's first plug in 2. 2 plus 2 is 4. The square root of 4 is positive 2. Positive 2 plus 1 is 3. Now we plug this into the other equation. And we say 3 minus 2 is 1. And the square root of 1 is positive 1. We said this side was equal to 3, this side is equal to 1. That means this does not work. This is extraneous. And you'll notice that, and I think I said this very briefly above, a lot of these stem from square roots, or really even roots, because, for example, when we plug in the 2, and it's 2 plus 2, and when you take the square root of positive 4, technically, as I said before, negative 2 times negative 2 would equal positive 4. But we always assume that the square root is going to be positive. But if it were to be negative, which when we sort of do this out, it sort of messes it up. If we were to get negative 2, we get negative 2 plus 1. That's negative 1. We assume that the square root of positive 1 is negative 1. Like, that's sort of why we're getting 2 as a possible answer. But when we're actually plugging it in, it's extraneous because it goes against essentially the rules of math, which is, say, you kind of have to assume when you're solving these equations that the square root's going to be positive. Okay, anyways, I digress. Let's plug in negative 1 for x. So we do negative 1 plus 1, we get positive 1. The square root of positive 1 is 1. 1 plus 1 is 2. X minus negative 1 is going to give us positive 4. The square root of positive 4 is positive 2. So that does work out. So x minus 1 is going to be our answer. Okay, so I know we went over a little bit in this lecture on solving radical equations. So if you do have any questions, of course, talk to Mr. Whitaker, talk to your peers in your class, maybe some upperclassmen. Feel free to reach out to me go to the tutoring center, use the internet, take advantage of all the resources available to you. And I'll be posting another video shortly on just some more practice with these types of equations. Okay, great. Have a nice day. See ya.